Lab 10, The Integral and You, starring Ryan Eaton, Spencer Nash, and Stephen Fortney.
I know everything from limits to derivatives, but golly, this integral is a toughie.
I'm Dr. Calculus. What seems to be the problem?
This integral I'm looking at, I can't seem to do it by hand.
I know just what the problem is. You see, you can't do this by hand.
Really?
Yeah, I know just what you need. A TI 83 plus.
You see, this is the problem I'm having trouble with. I'm trying to find the area under the function f of x between x equals 1, x equals 2, and the x-axis.
You see, you can't integrate this by hand, so simply plug in f of x into your y equals screen and use the integration function to evaluate it from 1 to 2. That gives you your area.
Genius.
Look
The
at
answer
there.
is 0.952. I would have never gotten that unless I had my handy-dandy TI-83 plus. Gee, Doc, I wish there was a way to graph the integral function.
Well, you see, there is. If we simply graph the integral function in the TI-83 plus from 1 to x, it yields the following graph.
Get out of town.
At this time, please pause the video for further instruction and questions.
So what happens if we change the lower limit from 1 to 2?
Good question. What do you think?
Well, since the new lower limit is 2 instead of 1, it forces me to believe that the new x-intercept will be located at x equals 2, meaning that the previous integral function will be translated 1 unit to the right. Take a look at this graph.
Graph. At this time, please pause the video for further instruction and questions.
So assuming the lower limit is any constant, k, that is where the x-intercept will be on the integral function. What do you think about that?
It's pretty nifty. This concludes our presentation on integrals. We hope that you've enjoyed it. We sure have enjoyed making it.
Well, everybody's heard about the bird. The bird's the winner, winner, bird, bird, bird.
We also hope that you're better learned as a result of watching this film. Please take what you've learned to heart, and remember that integrals are just as easy as derivatives or limits. It's just what you make of them.